Hi, and welcome to Mplus Workshop 6. This is a discussion of a structural model in structural equation models, and it is different than the EFA and CFA because what a structural model does is it takes the CFA as the measurement model as the starting point, and then it adds to it the regression, almost like a path model in between. It is in fact exactly a path model, but in between latent variables. The file we're using is Klein Chapter 10, and it is in fact the example from Klein's book on structural equation modeling in Chapter 10, and from this particular paper, which is also going to be available or is available on Canvas. So the variables here are variables describing job as fascinating, satisfying, boring, describing yourself as are you happy, and this is Underwood and Fromming. That kind of looks like a misspelling, but it's actually the name of the researchers. They had a mood scale, a dysfunctional thinking scales, several of those, and these are composites. There's approval by others composite, and evaluating beliefs and assumptions subscale, self-talk subscale. Okay, so they evaluate the degree of working through tough situations using self-talk, and evaluate degree of working through tough situations using visualizing successful performance composite. So these are the variables. This is actually a summarized format. So all we have are the standard deviations and the covariance. Let me open that file. So again, just a great idea to always open your data file to make sure that it looks right. So you can see that these are the standard deviations of 12 variables and the correlations of those variables. Okay, so that's in our set of files. And we have a number of INP files. We have the SEM file, the structural file, and the structural file version 2. Maybe somewhat awkward wording or labeling, so sorry about that. I'm not particularly creative about that. Okay, so here is the first file. So what we're trying to do is we have all of these and all these variables, and the researcher has a theory that these manifest variables are actually predicted by latent variables. The latent variables being job satisfaction, and that's a latent variable by work 1, work 2, work 3. SWB, that's, what is that? I forget the name of it. SWB is subjective well-being, and dysthink is dysfunctional thinking, and conthink is constructive thinking. So actually, we're thinking job satisfaction by those 3, subjective well-being by those 3, dysfunctional thinking by those 3, and constructive thinking by those 3. So the first thing we're going to do is we're going to run a 4-factor CFA model, allowing all factors to be correlated. Although I'm actually going to take a step back. I'm going to go ahead and take a look at, where is this one? Here it is. Okay. I'm going to take a look at this, and I'm actually going to take a step back, and let's see how I'm doing this. I'm actually going to say one factor, say it's job, I'm just going to say factor by, and then I'm going to list all of these variables. So often in our work, it's good to start with a 1-factor model. And so I'm going to go ahead and run that. And when I do, yeah. Okay. So we see that we have, so we have a starting point. So this tells us that the chi-square model fit is the value is 566. There's 54 degrees of freedom, p-value of less than 0.01, and that tells us that this model does not fit this data particularly well. And that's not surprising because we actually told it that there are 263 observations, a lot of observations, so it's hard to get a CFA model to fit in that way. But what we're going to do now is we're going to compare this to a second model. And I'm going to go back here. And I'm going to instead now put a comment in front of all of those and take the comments out of here. So I'm going to go back to the theoretical model. We actually have an a priori model structure that thinks that these load on 4 separate factors. So I'm going to run this and compare it. And I see that now I have a chi-square test of model fit at 62 and with 48 degrees of freedom, and actually the p-value is not significant, which means that the model and the data are not statistically significantly different. So that is a better, much better fitting model. I'm going to use these values in a calculation at the end. So now we have a measurement model that looks like it's a pretty decent fit. This is, of course, the speed version of doing this. You would want to take a lot more time than this in your work. But now I'm going to say, okay, so I guess we're satisfied with that. Can the model fit be improved? Well, the authors suggest allowing the error variances to correlate for 2 of the manifest variables. Those are mood 2 and happy. They think that it makes sense to have those correlated. So let's take a look what would happen when we correlate those. All right, so what do? We want to correlate mood 2 with happy. So mood 2 with happy. So remember, right, one of the things I talked about from the very beginning was that if you don't actually ask Mplus to do something, you don't know exactly how it's going to, it has all kinds of different defaults. So if you don't say they're correlated, the correlations will be constrained to 0, so that will assume they're uncorrelated. All right, so this actually, by doing this, it actually allows these are the residuals, and the residuals will be correlated. All right, so let's run this. Yeah, save it. Okay. And so now my chi-square test says that the value is 56.662 with 47 degrees of freedom, and the p-value is even higher. So yes, that did improve the model fit, but I don't know if that was a statistically significant improvement. So I'm going to share something with you really quick. This is a spreadsheet I developed for analyzing the model fit. So ignore from 6 down for now. Let's just start with these first 3 rows. I indicated as 2, 3, and 4. So this is the first one-factor model. That's the chi-square for the model and the degrees of freedom for the model. In the next row, I show the same measures for the 4-factor CFA. In there we have the chi-square is 62.468, and there are 48 degrees of freedom. And so if you take the difference, 566 minus 62, you get 504, and the difference in the degrees of freedom is 6. So then this calculates the chi-square, and we see that it is basically very, very small, less than 0.01, less than 0.001. So the improvement in the models by identifying a 4-factor model is significant. So the 4-factor model has better fit, statistically significantly different, and it is in fact an improvement. So you're losing degrees of freedom. So you're going from 54 to 48. So you're adding complexity to the model. But when you add complexity to the model, but you get a statistically significantly improved fit, that's okay. You prefer the more complex model with more paths or more factors. And then in the last step there, 4-factor CFA with correlated error, you see the chi-square, the degrees of freedom, then the difference, that's here, and then the degrees of freedom of that, that is also less than 0.05, so this improvement is significant. So the 4-factor model with the correlated error let me put that in there, forecast model with correlated errors has better fit. All right, so the 4-factor CFA with the correlated error has better fit. So that's going to be our choice model going into our structural. So in our structural model, we're going to add relationships between the latent variables that represent regressions. So let me take a pause and I'll bring that up. All right, so let's see where we are. Okay, we're in step 2. So we're going to use this W6 demo 22 underscore SEM underscore structural. And we're going to model the structural model, which reflects multiple regressions. So we're going to model dysfunctional thinking on constructive thinking. We're going to model subjective well-being on dysfunctional thinking and constructive thinking. And we're going to model a regression of job satisfaction on constructive thinking, dysfunctional thinking, and subjective well-being. All right, so that is going to be our next step. There it is. So you see here we have all the same, the 4 factors, I'm sorry, the 4-factor model. And actually I'm going to move this up here so it's not so confusing that is in fact, we're trying to make this a little bit chronological. That did in fact actually come next. And there is our model. And what am I calling this? I call this the structural model. And okay, so I'm going to run this. And we can look down here at the estimates and we can see those are our factor loadings. And there's our correlation. And here are our regression coefficients for each of these 3 regressions. And what we see is that there are a couple, certainly SWB on ConThink and job satisfaction on ConThink, that are not significant. One of the tactics that's taken often at this stage is you want to trim the non-significant paths and see if the model fit is better. Well, let's take a look at the model fit, 56.62. I'm going to go ahead and look at here. See, we have actually added paths in a structural model. So from the measurement perspective, it hasn't really changed it any. And that's why there's really, when you go from a factor to a full structural model where all the paths, it's called just identified, all the paths are there. So there's no change in model fit. All right, so we put that in. Now, to see, we want to see if it would make a difference if we were to trim these 2 paths. So in order to look for that, I'm going to look at SEM structural version 2. So let me go ahead and open that. Let's see, version 2, V2. I have that here. And so here I have removed this from these 2 regressions. I've removed this. Put that there. There it worked. All right, so we have the factor, the measurement models with the 4 factors, the correlation, and then the 3 regression equations with constructive thinking removed. We're going to run this. And we'll see now the factor loading should all be the same. You can go back and check on that. Here, everything is significant, except this is a little over 5%. So maybe that could be a problem we might want to look at. But right now, let's just look at, here is the chi-square and the degrees of freedom. Let's look back here. Okay, so I put that back on this measurement model and structural model comparison chart of model fit. So here's the chi-square for the model, the degrees of freedom. Take the difference, and again, you can see from the function line up here that that's just a difference, that's just a difference, and this is calculating the chi-square. So the change is not significant. And so one thing to notice is I'm going here from a simpler model to a more complex model. So if the improvement is significant, the more complex model is better. Here I'm going from a more complex model to a simpler model. The change is not significant, therefore we prefer the model that is simpler, and that's the one with the fewer degrees of freedom. just a reminder that as you, depending on the direction it's going, the degrees of freedom, increasing the degrees of freedom or decreasing the standard is different. That is a good way to look at a complex model where you have a measurement model and you need to test hypotheses on regressions as well. This could go and become very, very complex. So good luck with your own models, and let me know if I can help.